All right, today we're going to talk about compound inequalities. So let's start talking about the definition first of all. And a compound inequality is two inequalities that are joined by the word or words and or the word or. I guess I shouldn't have this S in there. So let me give you a couple examples and we'll talk about the graphing aspect of it first. Okay, so here's a good example of a compound inequality. Okay, so the way you say that is you start with the variable in the middle and you go left and then right. So you would say x is greater than 2 and less than or equal to 5. Okay, this is what we call an and statement. Okay, and so what this means is all our numbers, all the answers that we like, are between or are bigger than 2 and less than or equal to 5. So how do you graph that? Well, we obviously have a 5 and we have a 2. So let's just start with this part first. X is bigger than 2. Well, that means there's going to be a closed circle right there. And all the numbers that are bigger than 2 are this way. Now, I'm not going to finish it quite yet. What about over here? If I talk about this, x is less than or equal to 5. That means it's a closed circle. Less than or equal to would mean it goes this way. And so it's all the numbers that are between 2 and 5. Any answer that I pick in here, 3, 4, 2.5, are all numbers that are bigger than 2 and less than or equal to 5. Okay, let's try another one. Okay, so the way you say it is x is greater than or equal to negative 3 and less than 6. So I want all the numbers that are greater than or equal to negative 3 and less than 6. So I go close circle for the less than or equal to. It's all greater than that. And over here it's less than 6. So it'll go here. So there you go. Now they're not all like that. Sometimes we have or statements. Now how do I know the difference between an or statement and an and statement? Well, an or statement actually says the word or. X is greater than 4 or x is less than 0. So the way I would say this, or the way I would write this, is you just treat them separately. So let's say here's 0, here's 4. X is greater than 4 goes this direction. It says x is less than 0 goes in that direction. And there you go. And traditionally, not always, but traditionally, or statements look like this, where they're going opposites of each other. And traditionally, not always, but traditionally, and statements connect. So let's try one more. What about x is less than 1 or x is greater than or equal to 7? There's 1. Over here is 7. Less than 1, greater than or equal to 7. And there you go. Now, what if we go backwards? So what if I asked you to write the solution? So what if I give you a graph? Okay, say it's this. So what would be the compound inequality that would create that graph? Well, this is going to be an and statement. I know that because they're connected. Okay, so we're looking for all the numbers that are bigger than negative 6 and less than 8. So using set notation, I would write whatever variable you want. I'll just use x, all real numbers x, such that x is greater than negative 6 and less than or equal to 8. Just like that. Let's try one more. What about one that would look like this? Well, hopefully this is an easy one. You see this one has arrows going opposite directions, so we know this is going to be an OR statement. So we'd say, let's use a different variable. How about a? All real numbers a such that a is less than or equal to -2, or a is greater than 3. Okay, so far that's it for part 1 of compound inequalities.